Hello everyone, happy Wednesday. Before we begin, I want to do some birthday shout outs. I missed Riley's birthday on Monday's video, so sorry about that. Riley's birthday was the 15th, and then Emma's birthday is Friday the 24th. So happy birthday to you girls. We're sorry that we can't celebrate with you. Okay, so before we begin, let's go over the 3 problems from the last video that you should have done on your own. I have the answer key right here. I just want you guys to make sure that you have the same table as me and the same graph as me. Domain and range was optional because I didn't have you do that. So if you have it, great. If not, no big deal. I'm just gonna highlight a couple pointers. Remember with this one, make sure -1, 0 was your first point. Make sure you started here with no arrow and you went on like that, okay? You can take a look at the domain and range if you want. Since it moved to the left one, that just changed the domain only, okay? Graph number 2. This one moved down to, I misspoke when I was making this Sunday night. Sorry about that. This one moved down to, I think I said right. Because it's on the outside, it moved down. So the normal 0, 0 point would be your middle point. It moved down to, so as you can see, it looks like that. Make sure you had your 3 middle points. You should have the same 5 points I have. One above that and one below that, okay, so that you get the full S going on here. Okay, and then graph 3 was your exponential. This is exponential growth because it's going low, 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 and then shooting up like in the roller coaster, like the dragster, if you've been to Cedar Point. So this is exponential growth. The numbers are getting bigger, which we're gonna be talking about a lot more today. Make sure you have a couple decimals so that you show it went really close to that x-axis but didn't touch, okay, and make sure you didn't touch it. And then you should have graphed just about the same points as me. Your domain is staying all reals always, no matter how it moves. And your range, this one didn't move up or down, it just moved to the right 3. So the range is still gonna be from 0 to infinity without touching 0, okay? All right, moving on to today's lesson. Today's lesson is gonna be writing exponential equations. So go ahead and grab your separate sheet of paper. And some of these questions are coming from your note packet, so if you can find them in there, I'll try to guide you, but since I'm jumping around quite a bit, I'm just writing on a separate sheet of paper. So this is going to be writing exponential equations, and this video is from 4/22, so it helps if you guys put the date on there for me when I grade, okay? So the notes are gonna be first. And before we begin, I just wanna show you a couple of things about exponentials, okay? So on your paper, I want you to write on the left side, exponential growth, and you can abbreviate that. And if I'm ever going too fast, guys, I'm going fast so that I don't bore you too much. But if I'm going too fast and you are having a hard time keeping up with me, please hit pause. I know I can talk fast. Okay, so exponential growth versus exponential decay. If I'm looking at a graph, I want you to know what that looks like on a graph first, and then we're gonna look at tables, and then we'll look at equations. So you can see what growth looks like in all 3 ways, same with decay. Exponential growth is gonna look like this. The exponential goes like this and then it curves way up, and it's gonna go in this direction where it starts low on the left and shoots up on the right. I think of that roller coaster, the dragster. If you've been to Cedar Point, it just shoots you right up. You go up really fast. Exponential decay is the opposite. You start high and you go low and then you bottom out right there. So that's what an exponential decay is gonna look like if you were to graph it, okay? If you're looking at a table, so your x, y values, in a growth, your y values are gonna grow. They're gonna get bigger. So if you have something like 0, 1, 1, 2, 2, 4, 3, 8. Notice how my y values grow here. They get bigger, 1, 2, 4, 8. And we're gonna talk about what those numbers do in a second when we actually write these equations. In a decay, your numbers are going to get smaller. So let's say I start with 0, 27, 1, 9, 2, 3, 3, 1, 4, 1/3. Notice how these numbers are starting high, going down. So that would show a decay, okay? Something that depreciates or decays is like a car's value, okay? When you buy it and then you wanna sell it 3 years later, it's going to, the price will go down, okay? So I'm not gonna highlight that since I smushed those, so just so you know, that's what it looks like. All right, Now leave a space for what the equation looks like. We're gonna write in that in a second. So we're gonna show you what two different equations would look like here. After I teach you how to write an equation, okay? So just leave that blank for now. All right, to write an exponential equation, I'm gonna bring you guys back to that example that we did 2 days before what seemed like the world ended and we never went back to school. And that was that penny problem where the father asked his dad if he could, instead of getting, I think it was $4,000 a month for his allowance, he was like, okay, you know, that's a lot. So why don't you pay me a penny on the first day of the month, 2 pennies on the second day, 4 on the third, 8 pennies on the fourth day. And he kept doubling it until we were shocked to find out at the end he got this $10 million number, okay? This is an exponential scenario because we keep multiplying by 2, okay? Exponentials multiply to either get bigger or get smaller. In this case, this would be an example of exponential growth, right? It grew a lot just in 31 days, okay? When you write an exponential equation, so think about this example, and the key numbers I want you to think about are the starting amount and what you're multiplying by. Those are the 2 things you need to write an exponential, okay? And you're gonna see that in 1 second. So if you are looking at your notes, this is page 10, and what I'm about to do is at the bottom of page 10. But I'd prefer if you wrote it here so that's all in one spot, okay? So in nice big letters, I want you to write y equals a times b to the x. Make sure your x is small like an exponent, okay? You need 2 things to write an exponential equation. You need your a, which is, I'll tell you that in a second, and you need your b, which I will also tell you in a second. Okay. So your A is your y-intercept. I'm gonna write it, it's when x is equal to 0. Okay, these are all the same thing. Your y-intercept is when x is equal to 0. So if I was looking at a table, this would be my y-intercept here. This would be my y-intercept here. Or it's your starting value. It's another way you can think of it. Starting value. Okay, so those are 3 things you can think about when you're finding your A. All right? Your B is your growth or your decay factor. Factor, we use that word and it's representing multiplication. So it's your growth or decay factor. It's what you are multiplying by. So it's what you multiply by, okay? So I'm gonna show you guys our example problem. Our example problem, and this should make sense to you, that represents the penny problem is this: y equals 0.01 times 2 to the x. Okay, notice my a in this case is 0.01. That's my starting amount. That's how much the boy said he would start with, right? He said, okay, give me a penny to start with. So that's his starting amount. 0.01 was the starting value. And 2, if you remember what the 2 is what we multiplied by. He doubled, right? And you multiply by the same amount. So 2 is what he multiplied by. That's his growth factor. So what was multiplied, we're gonna say. Okay, so let's think about these 2 things, my A and my B, and you can use this equation if you need something to stick it to. So remember that A is, 0.01, my starting amount. B is what I'm multiplying each number by to get to the next number, okay? I'm gonna show you 4 examples, and then I'm gonna give you 2 or 3 to do on your own, okay? All right, so let's go ahead and get started here. First example, I'm gonna try to keep them all in this space on 1 page. I'm trying to keep this all 1 page for you guys. All right, first example number 1 is going to be your x, y. You write -2, -1, 0, 1, and 2 for your x values. And then we're going to write 0.25, 0.5, 1, 2, and 4 for your y values. Okay? And I need my equation to be in y equals a times b to the x, where I need my y-intercept. I'll highlight these for you. I need my y-intercept, and I need my growth factor, my b, okay? Let's start with the y-intercept because it's actually sitting right there in front of your face, if you can see it. Your y-intercept, remember, it's when x is equal to 0 if I'm looking at a table. So when x is equal to 0, my y value is 1. My a is equal to 1 here. So let's write that down. A equals 1. A equals 1. Okay, your b is your growth factor, what you multiply your y values by. So this growth or decay, these numbers are going up, which means I'm going to be multiplying them by a whole number, okay? And I like to look at the whole numbers, not the decimals. Decimals are tough. So if I go from 1 to 2 and 2 to 4, what number do I multiply each of those by to get to the next? It's times 2, times 2. And the same applies here. Okay, so my b is 2. So my equation here is going to be y equals a. You can or cannot put the 1 there. Only if it's a 1, it's optional. If it's any other number, you have to put it there, okay? My b is 2 to the x. Okay, so that's my first example. This is a growth equation. I want to show you something. The reason that makes this a growth is because I'm multiplying by a whole number here. I'm sorry, not a whole number, a number greater than 1. All right, 2 is greater than 1, so these numbers are going to get bigger. When you see your b value is a number greater than 1, that represents growth, okay? So if you're just looking at an equation and nothing else to help you, you would want to look at this number right here, the number being raised to the x power, to see if it's a growth or a decay, okay? All right, number 2. Again, if I'm going too fast, pause it and replay me. I just don't want to be going too slow at this point because I think this can be probably boring enough for you. So trying to make it not so boring. Although math can only be so exciting, right? Okay, these are your next points. So let's go ahead and do 0, 64, 1, 16, 2, 4, and 3, 1. Okay, I need my y equals a times b to the x. I need my y-intercept. And I need my, whatever I'm multiplying, growth or decay factor. So it appears again that the y-intercept's sitting right there in front of me. Where x is 0, y is 64. So that means my a value is 64. My b is what I'm multiplying by. Now, some of you might look at this and say, okay, these numbers are going down, so that makes it a decay, which you're right. So usually when we think of multiplying, we think of numbers getting bigger, but you can also multiply by a fraction, and that would make your numbers get smaller. It's harder to think about in your mind what fraction I'd multiply 64 by to get to 16, and 16 to get to 4, and 4 to get to 1. So here's a trick. It will always work. If you take a number below, like 16, and divide it by the number above, right? If I go backwards, I can divide. Instead of multiplying going down, I can go divide. So I can take 16. I'm going to show that work down here. If I take 16 and divide it by 64, let me do that in my calculator here. 16, you can't see, divided by 64, enter, you get a decimal. We could use decimals, but I'm going to make it a fraction by hitting math right here, enter, enter. 1/4, okay? So I'm multiplying, that's what I multiply by, 64 times 1/4, and if you don't believe me, check it in your calculator. Do 64 times 1/4 and see if you get 16, okay? Times 1/4, times 1/4, and so on. So 1/4 is going to be my b value, multiplying everything by 1/4. I should have highlighted these in orange too, sorry about that. So my b is 1/4. Which makes my equation y equals 64 times 1/4 to the x. Okay, now if you see what makes this a decay, if I don't have the table to look at, and I just am looking at this equation right here that I'm bubbling in, the number that's attached to the exponent of x, if that's a fraction, lower than 1. So if it's a number less than 1, then that means it's going to be a decay. Okay, so up here, I'm going to show you guys I'm going to quickly write these equations for you. I mainly want these as examples so that you can see the difference between a growth and a decay equation. Y equals, this equation would be 1 times 2 to the x. When this number is greater than 1, it's a growth, okay? This equation right here would be y equals 27 times 1/3 to the x. When this right here, your b is less than, in between 1 and 0, I should say, less than 1, it's going to be a decay, okay? So those are your 3 examples: graph, table, equation that show growth, graph, table, equation that show decay, okay? I'm gonna do one more example. It's gonna be more of a challenge. And then you guys can shut me out for the day and do the next problems you're on your own. The challenge problem is going to be write an exponential equation passing through the points 2, 8 and 3, 4. Okay. What makes this one more of a challenge is because I'm not given the y-intercept like I was in these tables. Okay, I have to actually do something to find it. So the first thing I'm going to do is put it in table format. And be careful when you do that. I'm going to leave space for where x is 0, right, because I want my y-intercept. And then it starts at 2, but I'm going to have to do 1 as well. You can't skip any numbers here, and you'll see why in a second. I'm going to fill in the numbers I have. So I have 8 and I have 4. And then I'm going to use those numbers so I can figure out my growth factor. So y equals ab to the x, or my decay factor. A is a mystery to me right now. I don't know what a is. I don't know my y-intercept. But I could find out my b. I know it's an exponential, so I know I'm going to be multiplying. What do I multiply 8 by to get to 4? Well, it's getting smaller, so it's going to have to be a fraction. So you can do the trick I taught you, 4 divided by 8. 4 divided by 8, math, enter, enter, 1/2. Oop, sorry, sometimes I'm not paying attention. You can't see me. Okay, so 1/2 is what I multiply by. So that's my b factor, is 1/2. To go backwards, guys, you divide by 1/2, or you might be able to tell in this case, I don't want to confuse you, but to go backwards, you can always just divide by your b value, or you might realize that dividing by 1/2 is the same thing as multiplying by 2. So I'm going to multiply these numbers by 2. So 16 and 32. And the reason I did that is to get my y-intercept, which is 32. So your equation is y equals 32 times 1/2 to the x. Okay? So those are your two. I'm going to just do some highlighting here so that everything looks nice and pretty and matches up. I suggest you do the same if that helps you guys write your equations. You need 2 things: y-intercepts and growth factors or decay factors, okay? So here are your notes for today. Make sure you take those notes and hand those in as part of your work, as well as these corrected. So your questions from yesterday should be correct, or Monday should be corrected. I should see stars on here if you got them all right, or corrections, so I can see what mistakes you made, and you can see the mistakes you made, and then the right answer. Okay, so that's all gonna get collected together. And on the back of this page, let's go ahead and write your, I think I'll give you, what did I write out? I only wrote out 2 questions. You guys are, I was feeling nice today. Okay. So, question 1, I want you to write an exponential equation. You're actually going to be doing this for 1 and 2. So we'll call this 1A and B, I guess. Write an exponential equation for the following. For 1A, I want you to do it with using this table. The table is going to be 0, 3, 1, 6, 2, 12, 3, 24. And B, and these are not the same A and B like as your equations. This is just question 1A, question 1B. Okay, I don't want to confuse anyone. Passing through these points. The point 1, 9 and 2, 3. This question is like the last one we just did. I would suggest making your table, leaving room for where x is 0, and putting in your points 1, 9 and 2, 3. It's much easier when you see it as a table, okay, and then figuring out what you multiply by using the trick. All right, if you guys have any questions, please let me know. The answer key to this will be posted either on a video link or a link to an answer key on Friday. So you're still going to be correcting these and handing these in. So hang on to all of this, okay? Hope you guys have a great day. Bye-bye.